All right, now that we know how to construct perpendicular lines and angle bisectors, let's talk about some properties of angle bisectors. First of all, for a given angle, and imagine that you have the angle bisector here, any point P on the angle bisector is the same distance away from one side of the angle as the other side. Also, any point that's equidistant from the two sides of your angle has to be on the angle bisector here. So we're going to use that idea to construct the incircle of a given triangle. So the last section, you circumscribed a circle around a triangle. This time we will construct a circle that lies right on the interior of the circle that just touches the sides. All right, so the first thing we need to do is find the center of such a circle. So imagine this. If you had the line segment that bisects angle A, then any point on that line will be the same distance away from AC and AB. And if you bisect the angle B, then any point on that bisector will be the same distance away from these two sides. So where do these two bisectors intersect? Whatever point that is will have the same distance away from this side as that side. So what I need to do is construct the angle bisectors for at least two of these angles, and that will give me the center of the circle. So let's go ahead and do that. To construct the angle bisector, what you need to do is to create a little rhombus where this is the vertex of one of your rhombuses. So I'll set my compass point at vertex B, and I will draw an arc on the two, intersecting the two sides of that angle. And then I'll take that same length, that same distance, and make an arc from this intersection point, and then another arc from the other intersection point, and that gives me the last vertex in the rhombus, and I can go ahead and connect the dots. So I have bisected the angle B. So now any point on this bisector is the same distance away from either of the two sides of my triangle. Now let's go ahead and bisect the angle A. I'm going to change colors here. And imagine that I'm trying to construct a rhombus where this is one of my vertices. I'll draw an arc to intersect the two sides of my triangle, or my angle. Then move the compass to that intersection point and the other intersection point. And then I will connect vertex A to that intersection. It's getting a little messy in the inside of my triangle here. All right, so the point where these two bisectors meet up, that will be the center of my circle. So again, what you think is any point that lies on the intersection of these two bisectors has the same distance from BC to AB to AC. So this is the center of my circle. Let me call it O. So here, O is the point where the bisector of angle A and the bisector of angle B meet. So it's those two intersections. All right, so that's the center of my circle. And then, if you want to be really precise about things, we need to find the radius of the circle. So what I'll do is maybe the rhombus method to find the line perpendicular to any one of the sides. I'll use side BC because it's the cleanest side so far. That goes through the point O. So I'll use the rhombus method, set my compass point here, and I need to draw two intersections. So two arcs that intersect that side. And then I'll move over and draw an arc from each of those intersection points. All right, that gives me now a line segment perpendicular to the side through the point O. So that, whatever that length is, that'll be the radius of my circle. Let's go ahead and draw in that circle. I think I'll use, what color will I use? I'll use this green color. So setting my compass at the center and the length to that distance there, the distance that it just created by constructing the perpendicular segment. I will draw the circle. And again, this is sort of the opposite of circumscribing the triangle. It's constructing a circle that just touches the sides of the triangle and is contained completely inside. All right, and just to recap here, we've done a whole bunch of constructions, and there's one thing clear, is that a rhombus is a useful tool for constructions. And the reason a rhombus is so useful, number one, is they're really easy to draw. They're easy to construct. All four sides are equal. Since all four sides are congruent, really all you have to do is set your compass length once and then draw a whole bunch of arcs that represent the same distance. And wherever you have intersections, that represents a vertex of your rhombus. So they're super easy to draw. And then we have that the diagonals are perpendicular bisectors of each other. We also know that the opposite sides are parallel. So if you need to draw parallel lines, you can use a rhombus. If you need to draw perpendicular lines, you use a rhombus. Also, the diagonals are the angle bisectors of the vertex angles. And angle bisectors are useful for, well, for making in circles. And they're also useful when constructing different angles. Like, so for example, if I wanted to construct a 45-degree angle, I can use a rhombus to construct a 90-degree angle, and then I could use another rhombus construction to bisect that 90-degree angle, and then you have a 45-degree angle. So rhombuses are super useful, and you'll see them used over and over again in constructions.